The whole purpose of this page and the next page in your book is to show you that you can solve for a unit rate for hours and also solve a unit rate for lawns. So what I want you to do is read example 1, fresh cut grass, get the gist, and then we'll come back and talk. Your VIPs for this first example are the two ratios that they give you: 3 lawns in 5 hours, that's you, and the friend can cut 5 lawns in 8 hours. So we're just going to plug it into the template, 3 to 5, and the friend does 5 and 8. So what we're going to do, since this first example has hours on the bottom, we're going to solve for the unit rate for hours. We want to figure out what you and your friend can cut in 1 hour. So 1's going to come on the bottom, and we're going to go through division like we've normally have done. When you divide, you're dividing by 5 here. It's really important to remember who's inside the house and who's outside the house when you do long division. So who's outside, the 3 or the 5? Jay. The 5. 5 goes into 3. Since we're dealing with a number that's less, it's going to be less than 1, we got to add a decimal and a 0. Okay, go through it and get an answer. It's going to terminate with the first digit. All right, Lil, what do you got? 0.6, right? Okay, that's telling you now, what does this mean? That you, in 1 hour, can cut 0.6 lawns. That's less than a full lawn. It's about 2/3. Okay? In 1 hour. Now do the friend. Our multiplication factor now is going to be dividing by 8. I'll ask you the same question. Who's in? Who's out? Jay, I'll go back to you again. Yeah, 8 is out. That's going to put 5 in. And watch what I'm going to do. I'm going to give you a little sneak peek. You're actually going to need 3 zeros before it terminates here. Okay, I'm going to pause it and then we'll come back with an answer. So after we've done the long division, we get 0.625. I'm going to put it in here. Now the first question I got to ask you, because a lot of kids didn't know this, between this number, 0.625, and 0.6, from our above example here, which number is bigger? Brandon, do you agree? Who agrees? Who disagrees? See, I'm finding an area of weakness is comparing the numbers that are less than 1. Does this help you? 0.600. That's really what that number is. Which number is larger, 0.625 or 0.600? Lil? All right, who agrees? 0.625. A majority of you do, and it is. 0.625 is larger than 0.600. You have to get that into your head first before you now look at their ratios to determine who's working at a quicker rate. What this is saying is you are working at a rate of 0.600 lawns per hour. In 1 hour, you can mow 0.600. Your friend, same amount of time, 1 hour, does 0.625. Who's working at a faster rate? Literally. Why? So in essence, what I'm really asking you is, in 1 hour, who can mow more lawn? Say it again, Lil. A friend. So they are more efficient and they are mowing at a higher rate. So in our explanation, The faster rate is the friend is faster because he can cut, or she can cut more lawn in 1 hour. Before I can go on with you, I've got to make sure that you're 100% clear on this. Because if you have any questions, you can ask. If you're still not sure why, please, because when we get to the next example, I don't want it to further confuse you. Lean. Okay, ready? Same amount of time when you found unit rate for hour, 1 hour, 1 hour. Since 0.625 is larger, then this person, your friend, can cut more lawn than you can because they're working faster. Got it? Okay? Seals. Watch what we're going to do next. It's coming. In example 2, go to the next page. We're going to solve for the unit rate for lawns. We did hours on this page. We're now going to do unit rate per lawn. Now, if everything works out, we should still have the friend working at a faster rate, but we're having them work at a faster rate for a different reason, as you will see. Hopefully you will see. So going back to the original example, hours and lawns for you, what should happen is the ratio should turn upside down. What was the rate again? Because I got to flip back and forth. What was the hours and what was the lawns for you? What was the hours? Is 5 hours. Flip the 1. We're still going to keep 1 at the bottom. Because now, if you notice, we're trying to find the unit rate per lawn. One single lawn takes how long for each. So now when we do our long division, who's inside the house and who's outside the house flips. You now should have 3 into 5.00. And down here, you're going to have 5 into 8.00. So now you're going to have a number that's greater than 1. And I'm actually going to do this with you. 3 into 5. Good. Bring down my 0. 3 into 20. Yeah, you can see it already, right? 3 into 20. 3 into 20. 3 into 20. And you can see you got the dog chasing its tail deal, right? So you have a repeating decimal. You got 1.66 repeating. Let's round it to 1.67. We did this with the money a few days ago. Do you remember with the exit ticket? Let's examine what this ratio means. This is saying that you, for one lawn, takes you 1.67 hours to mow one complete lawn, which is really 1 2/3 of an hour, which is really 1 hour and 40 minutes. Keep that in your mind, because if your friend can mow the same one lawn in less time, then they are at a higher rate. Ev. I rounded it to the nearest hundredth. Otherwise, because it's 1.6 repeating, I just wanted to keep it a whole a rounded number so we can comprehend it a little better. What's nice about 5 into 8.00 is it terminates a lot quicker. 5 goes into 8 how many times? Just say it. 5 goes into 30 how many times? It terminates, and now we have 1.60, which is less time, because this is now representing hours. What's less time? 1.67 hours or 1.60? Matthew. Therefore, same thing, which is what we should get. The friend is more efficient, but for a different reason. Because the friend can now mow that one lawn in less time than you. Does that make sense? Yes? Let's write it down. The friend is faster because he or she can mow one lawn in less time. And I'll conclude with this. The whole reason why I showed you this is you can essentially get the same answer for different reasons, either way that you set up your template. However, bottom line with all of this, Common Core wants us to solve unit rate problems involving time with time on the bottom. They want us to use whatever the time element is, in this case hours, solve for the unit rate for time, not the other quantity. So whether we're using hours, minutes, days, years, seconds, it's always going to go on the bottom from here on out. Which kind of makes sense, because when you're driving in your car and you're measuring how fast you're going, you're doing 55 miles per hour. They don't give you how many hours per miles on your speedometer. They tell you how fast you're going per hour, 55 miles an hour, 60 miles per hour. And the reason why we're able to do that is because you're solving for the unit rate for time. So we're going to keep time on the bottom no matter what from here on out, just so we're not confused. Clear? Let's go to the first example. I want to skip this page with the graph, or with the equivalency data table, and go to restaurant advertising. Read it to yourself, get the gist, we'll come back with the recording. Your VIPs are really your two given ratios. Darla, 350 in 2 hours, and Drew is 510 in 3 hours. Did you circle that? Or underline it? Yes? I want to skip this for right now of what strategies to use, and I'm just going to say, let's just go to TRF. Go to TRF, and then we'll go back and revisit why TRF works best for this. Set up your template. It'll be menus, and time's always going to be on the bottom now, so menus over hours. All right, let's do Darla. Karen, what's Darla's given ratio? Find her unit rate for 1 hour. Cav, what do you got? How many have 175? Okay, great. So she can deliver 175 menus per hour. All right, let's do Drew. I already have my template set up. As long as I keep everything in the row, I'm not going to rewrite my template. 510 over 3. Find his unit rate. Dan Donato. Sounds good. So who gets the $10 bonus? Jay. Why Darla? You got it, okay? Now, I automatically took you to TRF only because I want to show you what happens if you say, hey, wait a minute, I don't want to do TRF, I want to do an equivalency ratio table. Watch the dilemma that you come into when you do an EQ table. And I'm not saying that it won't work. It will. It just might take a little bit longer. With Darla, if you set up a table, and I don't want you to write this, just look. Menus to hours. 350 to 2. That's Darla. Here's Drew. Menus to hours. 510 to 3. I have to get to a common hour denominator. If I count by twos and I count by threes, I'll eventually find it. That's the easy part. But in order to find equivalent ratios, I have to count by 350s here. And I got to count by 510 here. Now I can take a look at this, yes. And I still prove my point that Darla is more efficient because she's got 1,050 in 6 hours compared to Drew, which is 1,020. It still works. But there's a lot more chance of you making a math error when you count by 350s and count by 510s. That's why I think TRF is a little bit better method. Could you do it this way? Absolutely. You just can't make a math error when you're counting by 350s or by 510s. So the better way, I think, to do it is TRF. Take you to the second example. Let's do TRF again. And then we'll see how it plays out if you do an equivalency ratio table. Two animals, 60 feet in 4 seconds, and the gazelle, 100 feet in 8 seconds. Let's do TRF. Cheetah first. Feet over seconds. 60 over 4. For the cheetah. Here's the gazelle. $100 over 8. Find the unit rate for both, guys, and then I'll come back. Many of you, as you're going through this, are already realizing it's just so much easier to do equivalent ratios. If you find the unit rate for the cheetah, 60 divided by 4 is going to give you 15. No big whoop there. That's an easy one. When you're doing 100 divided by 8, now you got to deal with decimals. You wind up with 12.5. No doubt, based on the unit rate, the cheetah's faster. What I'm trying to show you is that maybe TRF isn't the best strategy for every single problem. As Leah pointed out, she saw, wait a minute, we have 60 feet in 4 seconds, 100 feet in 8 seconds. All I really need to do is make an equivalent ratio, which is like a ratio, an equivalent ratio table. 8 seconds is going to give me 120 feet. Now I can compare. What's faster in 8 seconds, 120 or 100? Just say it. So in this case, an equivalency ratio table is a better strategy. The whole point of this lesson, is trying to figure out what strategy works best. Not necessarily the strategy that works best for you, although that's fine too. But there are some strategies that make more sense to use for certain problems. Seals. But when you're doing it in your head, you're coming up with equivalency ratios. Whether you doubled this or split this in half and made it 50 over 4, you're doing equivalency ratios. You're just doing it in your head. Right, 4 is half. Right, you split this in half. Did you? You split this and made this 4 seconds, 50 feet. Did you do it that way? What'd you do? What did you do in your head? Tell me what you did in your head. Right, so you wound up splitting this in half, though. You made an equivalency ratio 50 in 4 seconds. You split 8 seconds in half and made 4 and split 100 in half, right? And then you can compare 50 to 60 and realize 60 is faster. I mean, even when you do it in your head, there's a strategy being used. Okay? All right, let's move on. You guys have about 5 minutes left, right? With this example, what do you notice is causing an issue? Emily? Okay, very good. We have 2 different time measurements, seconds and minutes. When you set up your template, we've got to convert one. You could convert either one, but one is better than the other. So you got to think it out. What do you want to convert? Minutes to seconds or seconds to minutes? Brandon, what do you think? Pick one and we'll take it through the process. All right, you want to do minutes to seconds. Let's set up a template. Words, you want everything to be seconds? Okay, we'll do seconds. Set up your template. Words to seconds. First ratio for the secretary. Actually, no. Because you actually have picked the better way to do it. You have. Okay? You've made things easier for yourself. Exactly. Watch what we're going to do. 225 words. 3 minutes is how many seconds? That you got to be able to do in your head. 3 minutes is how many seconds? Go. 180. I'm going to do the second one. Words over seconds. 105 over 90. What can I do now to compare these 2 ratios? Times 2. Which is what you've done is you're making an equivalency ratio. You now get 210 over 180 under the same time element. Who types faster? The secretary could type faster. Okay? Now, just in case you're curious to know what the slide would have been, but we're out of time, I was going to split you up into 2 groups. One was going to convert to seconds, and one was going to convert to minutes, and then we would come back. You would get the same answer for different reasons. Okay? We'll stop here for today.